Thank you. Welcome to this presentation called Oracle Internals for Developers. I was here last year. I did 2 presentations. Was anybody here and heard me last year? Excellent, okay. If you didn't hear me, you will find those videos on YouTube. So I might refer to one of those during the presentation. Okay, I'm from Bergen. I live in Norway. I work in a company called Right Consulting. I do most of my work in Oslo. I used to be a DBA. That's kind of a tough thing to be at the Java conference, being an Oracle DBA. So please be nice. The last 10 years, I have worked with Java developers in development projects. I've been working with SQL Server, different databases, SQL Server, MySQL, Oracle. Right now, I'm in a project where we kind of want to move a lot of the data from Oracle into Hadoop, using Oracle as the interface to the Hadoop data through a product called Gluent. So, yeah, this is our agenda for this presentation. I'm gonna try to show you why should you actually care about the Oracle internals. I'm gonna go through some internals. I'm gonna have some quizzes and some prizes. And my first prize is gonna go to that guy giving me the switcher. Thank you. Okay, so these are something I meet sometimes in projects. We are planning to switch our database from Oracle to MySQL Server. And I think, oh, that's fine. But do you really know what you're doing? So to explain what I mean, we have to kind of jump back to some of the principles of relational databases, the ACID. And you probably know this from before. You have the all or nothing, you have the consistency that you need, you have the isolation levels, and you have the durability. So let's look at the isolation levels. And those are described by 3 phenomena. And those are the dirty reads, the non-repeatable reads, and the phantom reads. The dirty reads permit you to read uncommitted data. And a non-repeatable read, you can reread a row, and it might show changes. The phantom read, a query might show different rows between different query executions. So if I have a table of accounts where I have 3 accounts, one with 100 something, 200, and 300. So if I, from transaction 1, do a select, I query account number 1, and the result is 100. On another transaction, I do an update with no commit. I do a second select, and I don't see the change. Oh, sorry, I see the change. Sorry, that's a dirty read. I'm allowed to read something that is not committed. So a non-repeatable read would be if I read the account, I did a commit, and I try to repeat, but I doesn't get the same answer. It's a non-repeatable read. And the third one, the phantom read, is I do a select, I get some rows. In the first, I get 1 row. Somebody else changes some data. Here I insert a row, and in my next select from that first transaction, do the same query, but I get 2 rows. That's a phantom read. So the ANSI standard gives me these isolation levels based on these phenomena. And what does Oracle support? It's not a quiz, no prize. It's the green ones, that's right. It's read committed and serializable. Yes. Yep. And very seldom used too. But, so, if you look at the standard, the standard tries to define different levels of isolation, giving different level of consistency. And the standard says that it is the repeatable read that claims to be guaranteed consistent. What is default on Oracle? Let's just jump a little bit. It's a read committed, which by the standard is not supposed to promise you a consistent read. So if I do something like that, this in Oracle, select balance from account where account number is 1, result is 100. I do an update. I do not commit. Now I update account number 2 to 200. And in the next select, I try to read number 2, but I don't see the change yet because it's not committed. What happens to another database? Well, let's say MS SQL Server. Well, you would do the select, you will update, and your row would hang. And when I do the commit, then I get the result. Well, then it will be consistent. So, what if I do this? I do a sum of balance. So now I have added a lot of rows. Now I have 100,000 rows, and the last row is, the amount is 200. So I started to do a sum. I want to see all of the money that's in my database. And after I've been reading maybe 1 or 2, 3 rows, somebody updates. It moves some money from the last account to the first account and commits. When the query is finished, it will be consistent. What about other databases? Well, if it was SQL Server, it will probably hang on some rows until the page that was being read was released. And in the end, you don't know. Are your data consistent? You don't know. It might be, it might not be. So you could change that in SQL Server or some other to repeatable read. Well, then you would, after your first update, you get it blocked. Yes, now it will be consistent, but it will have a lot of weights in your database. So sure, if you want to move from Oracle to SQL Server, that's fine. I don't think you should have all your data in Oracle. I think you should use Oracle whenever it's suitable. I use everything else, but I use Oracle when I need to. So, let's jump into the internals. Let's see how this works. And instead of doing that very detailed page, we'll do this one. This is what you're used to. You have your Java application, you have your connection pool, you have your relational database, and in your connection pools, you use JDK to maybe use probably you use the type 2 driver, or you might use the OCI driver that needs native C libraries. And your JDK client connects to the Oracle server, gets the Oracle server process, which will take all your queries. So what happens when I fire this query? So let's start from account where status equals active. Does it just fire this query? No, it happens a lot in the background. And that's what's really going on is something called Opi calls. And your Opi calls kind of change through or you get more and more Opi calls through the Oracle versions. So if I do, I think this is in Oracle 11. If I do a query against $V top level calls, I see all my Opi calls that actually are supported by today. And I see the open, cursor, parse, execute, fetch, close, commit, rollback. I have XA transactions. So I'm going to connect to the database as LG data. I'm going to create a table called big table where I just join and create 100,000 rows based on the all objects table, just to have a test table. I create an index on the object type column, and I start 2 traces. I start a Oracle 10,046 trace, which gives me what's going on the Oracle side, and I start a 10,051 trace that shows me the Opi calls coming from the client. So I just do this kind of the same query, not totally, it's a meaningless query, but that doesn't matter. Okay, so this is my trace, and I see on the top here, I see there's coming in some Opi calls, and I expected maybe something parse or something, but it does a V8 bundle execute, and that came in version 8. So instead of doing first an parse, then bind, then an execute, then an fetch, it does everything in one time. So I see the parse, bind, execute, and fetch, but what I see is that the first fetch only gets 1 row. So actually the execution could stop there. The client doesn't need to actually call another fetch if I only needed 1 row. So the parse thing, you probably heard 1,000 times before. It does a soft parse. It has to kind of validate the SQL. It has to check the columns, check the access rights, check the shared pools to see if there exists an execution plan that I can use. If it doesn't exist, it has to do a hard parse, which is very expensive, that you really don't want to, unless it's a DD or a data warehouse query that's going to be run only once. So as a developer, you can actually go in and look at your shared pool. You can look at all your child cursors, which right now are in your shared pool. So here I query the v$SQL and look for SQL text having big table in it. And one thing in Oracle is the SQL ID, which is a unique identifier for the parent cursor. The parent cursor will show in the v$SQL area. But this is v$SQL, which is the child cursors. So here I see I actually have 2 different, do I have a pointer? No, I don't. I have 2 different representations of the same parent query. And that could be because I have 2 different users. It could be that it was different bind variables coming in. So in this occasion, I have 2 child cursors for the same query. But this v$view is very neat for you as a developer, because you have some runtime information of how many disk reads and how many buffer gets. And I'll get back to buffer gets. That's logical I/O. How many blocks did I have to read to fire this query? And this now it comes to the first quiz. If you were the DBA or developer, and we're going to evaluate these 4 queries, which one do you kind of question? Which one would you kind of look into? And some very good caramels. The last one, that's a good choice. You won't get the caramels. That's a good thing. I will soon give you the caramels. That's not the reason, but it's number 3. Number 3, yeah. Let's just take the last one. Well, the last one, I would kind of question it. Why do you do a full table scan of that table? Well, I must think that if you do that, you have a purpose of doing it. Maybe it's a batch job or wherever running through the table. So if I look at the buffer gets compared to the rows gotten, well, that isn't that bad. I'm not even reading 1 block per row. If I look at the third one, I would see that I'm almost reading 2,000 Oracle blocks to get 1 row. And that's not good. Most developers would look at that query, oh, let's look at the execution plan. This is the execution plan for that query. And most would look at that and think, oh, that's okay, it's using an index. Well, fine. And this query would run very fast. It will be like 10 milliseconds probably. Why bother? Well, it might not be fast enough. Or even if it's fast enough, if you have thousands of those queries, you don't want them to spend 2,000 logical reads when it maybe only needs to do 5. So what happens here? Well, I do a range scan on the type. I read the row ID, I'll get back to that row ID, and I look up all the blocks where I found that type, and then I filter on owner. So if you look at the counts here, I look up 59,000 different rows, read the table block, then to filter out the 10 rows that had the owners. Yes, it was pretty fast, but if I made an index both with the owner and the type, it could filter everything right away. Okay. That was binds I do very quickly. Just remember to do binds so you don't get hard parsing. There are some exceptions where you might want to use literals instead, especially if you have unskewed data and you have frequency histograms. But let's just execution. That's the easy part. That's when you Oracle just start to run your query, and then we come to the fetch. So let's jump into the fetch. I asked my DBA to create this role called plus trace role, and I grant this role to myself. So after doing this, I could log on the database and start something called auto-trace statistics. So when I now run this query, I don't get the rows, I only get the number of rows that query got and some statistics. And if I look at that statistics, I see that that query did almost 8,000 consistent reads. So a consistent read, that's the same as a buffer read. I read data from the memory. And I also see that it did almost 7,000 round trips from the client and back. So if I divide that 100,000 rows on that number of round trips, I find a number called, or very close to 15. And remember the last page where you saw the rows equals 15? Well, that's because my client asked for 15 rows. And in SQL Plus, which I'm using here, the array size is 15. So what if I change this? In Java, it's called fetch size. So array size is the same as fetch size. So what if I change that? I set the array size to 500. I do the same query. What happens? Well, why is that? 1,500. This is not a quiz, sorry. But why do I read now 1,500? I read the same data. Last time, I read 8,000 blocks. Well, it's because I have to reread all the blocks again. Because if I ask for 15 rows, Oracle will go to the blocks. Maybe there's more than 15 rows in that same block. So I read the 15 blocks, get it back to the client, and just leave that block. I cannot hold that block. So database is left alone. Suddenly the client comes in again, give me 15 new rows. Well, I have to go back to the same block again. So I keep reading the same block over and over again. You see, and the round trips went down to 200. That's latency. That's a latency we don't want. Yep. Yeah, that's true. Yeah, you need to know if you. Yep. But actually, you don't do that because you just read. You just take your 15 rows, or if you don't have 500, you know you're finished. If you reach 500, you just send those back. Yeah. Okay. So in Java, you could easily set that, and you should set that. What is the default fetch size in Java? 10, that's right. Yeah. Is that a good fetch size? It depends. Tom Kite always answers, it depends. Good answer. You're not going to get it. I only have one left now, so. Good working. So, yeah, you really should consider your fetch size. It might make a big difference. Okay, so now I have my execution plan. I'm ready to do the fetches, so I need to read data. And the data are stored in Oracle blocks. And, well, first we store them in something called table spaces. And table spaces is just a logical representation of some files somewhere. So I don't have to worry about where the files are. I just say that this table, I'm stored in this table space. This index, I store in this table space. In the table space, I find my segments. It could be a table segment, it could be a partition, it could be an index. And each table consists of extents, which is continuous Oracle blocks. So if I have a table like this, some blocks will have data in them, and some will be free. And if I do select a table scan, what happens? Which blocks do I read? Of course, the ones with data in it. No, I read every block from, come on, that was the wrong one. Yeah, every block up until the high water mark, as far as I have ever put some data. So if you delete all your data and still do a full table scan, like a batch job, you would read the whole thing. So a smart thing, if you often delete a lot of data, make sure you reorganize that table and remove that high watermark to where it belongs. What about inserts? Well, if I do an insert, I have first, Oracle has to go to the free list, find a block that's free for inserts, then go to the block, insert my row. If I do a lot of inserts, that's not very fast, because every row I insert has to find a free block, go to the block, find a free block, go to the block. So what I can do if I have a lot of data that I need to insert is to insert them above the high watermark, doing an insert append. Then I just push all my data above the high watermark. But that's only when you do an insert, into, and a select, not values. That would never do append. So it's only batch jobs where you push a lot of data into your table. Okay. This is your block. Oracle block, 8K. You can have different sizes on the Oracle block, but 8K is most usual. You should stay on that. You have a header, you have a table directory, row directory that points down to all the rows. You have free space, and then you have the row data. And we're going to get back to this. The header has some information about something called system change number. That's the Oracle clock. You have a transaction ID that actually points to your transaction. It has an undo address. I'll tell you what undo is. And finally, you have all the rows in the bottom. So how does the Oracle row look like? Well, first you have some row header, and then you find all the column data. The row header tells you how many columns do you have, and then you start to traverse the columns. The first column, I find a column length, and then I find the data. I have another column length, and I have the data. What does that mean? Does it matter? Well, it does matter, because if I'm going to read the last column, I have to traverse that, spending CPU traversing. Is it a lot? Maybe not, but I still have to do it. What do you pay license for in Oracle? CPU usage. So if there are columns that you very often need, put them in front of the columns you very seldom need, because you spend less CPU getting to that column. Don't jump back home and rearrange all your data or your tables. You know, this is when really, really things need to scale. You might consider it. Okay, then you have the row ID. Row ID is a pointer to every row, or a single row, sorry. And the row ID is the fastest way to access your single row. That's important to know, because why don't people actually use them? I very seldom see the row IDs are used. So if I select something, well, I could select the row ID too. And in the next, when I'm going to update it, I update big table set owner equals something where row ID equals, then I go straight to my row ID. I don't have to go to the index to find that row. That's smart. Always there's somebody saying, well, could I trust the row ID? And then I must admit, no, you can't. So then you might answer, why do you want to use it then if you can't trust it? Well, of course, I don't write that query. I write this query. So I add the primary key together with that. Very seldom the row ID will be wrong. It could be if somebody did an update into a partition and it was moved by the update in the partition, you get some row movement. That will change the row ID. But most times it will be perfectly okay. And as long as I check that, it is this row that I actually want to update. And if it has changed, well, then I would just get 0 rows updated. And my application needs to check, why did that happen? Start to use the row ID. Okay, so the index uses my row IDs. So here I have a B3 index of some number row, and in the end, I see the row IDs. So I have my data sorted. So when I have a query plan like this, you see that the query plan, execution plan, is actually just functions. So I have a select statement, and the select statements need to find a table access by index row ID bashed. But that function needs a row ID. So it calls the index range scan that goes down, start to search for the every row I want, and find that row ID, pass that row ID back to the table access, which could go into that block and maybe filter some more, and then send back. Okay, but indexes are not perfect. This is a query in a project I just worked with. And the query kind of looks fine. It joins object details. I changed names of the tables so it won't look like anything that the application actually uses. And oops, it's an extra and there that shouldn't be there. Sorry about that. And it filters from time is bigger than 1 and 2 time is less than another. There is an index there on from time and to time. And okay, let's do this now. What's the trouble with this query? Oops. What's the you just think while I'm doing this, okay? What's the trouble? Anybody? It can use the index. Sorry, you won't get it yet. Okay, let me show you a picture. It can use the index, but it would have to read, if I use the from time, it would have to read all this. And if the from time was down here, I would have to read almost the whole index to get to those rows. Then I would filter out the to time afterwards. So here I need to do a little trick. Just that simple little thing, because I know that the from time has to be less than the to time. If it doesn't, the query doesn't really make any sense. So doing that, I'm telling Oracle that, yeah, I'm telling it that it has to be less than 2. So Oracle could take that and convert that to less than this number 2, which means that Oracle could just start read here, stop there. Okay. This is the same application, and this is even worse. They have made this generic solution. They have a lot of objects, and they don't know how many attributes the objects have. So they kind of just add rows to the object ref. So if the object have 3 attributes, they join 3 times. If it has 5 attributes, it joins 5 times. And if I look at the execution plan, it will use indexes. So again, what is the trouble here? Why is this not smart? Well, it's not just not smart, it's stupid. What is the trouble? If you try, I will give it to you, because you have been trying so much now. No try? Come on. No, that's a good try. I won't give it yet, but okay, I'll give it to you anyway because you were so close. There you go. That was the last one. Okay, the join order. How in the world is Oracle gonna know how to join these? Because when I filter here, that might be 500,000 rows. So if I join first with that, I only join one in one table. So then if that has 5,000 rows, I would first find 500,000 rows, then join those 500,000 with the next one filtering out. What if this one only had 5 rows? It would be a lot smarter to join that one first. Oracle can't know before it actually fires the query. Never, ever, ever, ever do something like this. This query was reading 500,000 Oracle blocks to finish, sometimes. It took like 3-4 seconds, and it was a batch job. Doing this thousands of times, that query, that job never finished. Why not? The data model was crap. It was never ever going to succeed. So by just rewriting that to a good data model, actually storing a good table for that object, having 3 data types or 3 entities, it went down to 5 blocks every single time we fired the query. And another thing is that reading 500,000 blocks, you would flush the cache. So all other rows or queries would also go bad, because it had to do I/O. So sometimes it can look very smart, but it could actually end up being very, very stupid. Yeah, straight columns as we always do. So actually what we did is that we left the generic part for those rows that didn't have a lot of those objects that didn't have a lot of rows. That didn't matter. But the object that really had a lot of data. So then we got the good part of both. We had the generic things for all those small tables, and we had the fast things for the table that was big. Okay, redo and undo. This, I think, is the last things I'm going to cover. How much time do I have? 40 minutes, that's good. I'm going to make that. Redo and undo is now we're going back to the first things I showed you about the ANSI, the ACID, and the difference between other databases and Oracle. This is where Oracle is very clever. This is what you pay for, and the locking. I'm not going to talk about the locking, but this is what you pay for. You have something called log buffer. So every change I do is written to the log buffer. And then you have a log writer that keeps writing all those changes to the redo logs down here. And that's sequentially. So it writes very quick all those changes. So every time you commit, it has to be written to the redo logs. You don't get a commit back before it's guaranteed written here. The data files is kind of, if I change a block, it might be there, so that's a lot more slow. So the database writer just writes blocks to the data files. It can be committed, it can be uncommitted, you don't know. It doesn't matter as long as you have track of what's committed here with the system change number, and yeah, it's basically the system change number. So we're going to talk about redo, we're going to talk about undo. So what is redo? Yeah, redo is for instance recovery. What if somebody pulled the blocks from the database? What if something goes wrong? Well, you always have your data in the redo logs. So it's for instance recovery. Undo is for rollbacks. If you change something and you regret, you want to roll back. And it's for something called consistent read. And this is really what makes Oracle behave like it was a repeatable read when it's on the read committed. So Oracle doesn't have to be on the lower isolation level because it behaves like that. It even behaves like, or it has the advantage of a dirty read still when it's on read committed. That's what really makes Oracle so strong. Writers don't block for readers, readers don't block for writers. So every time I do a change, if I do an insert, I'm going to record the delete statement. If I do an update, I'm going to record the opposite update statement. If I do a delete, I'm going to record insert statement. So let's look at read consistency. What happens when you do a select star from test and start to read blocks? Well, that query is fired at some point of time. Let's say that the system change number here is 2912. I start to read the blocks, and I see that my first block somebody has changed that. Somebody has changed this record. This is this is the only place where you actually see that a row is locked in Oracle. You have to go to the row to see if it's locked. So here, somebody has changed that. Writers don't block for readers. So if somebody has locked that, that doesn't matter. That's okay. But I'm not supposed to see that. Because my system change number, when I started my SQL, my system change number was this. So I'm not supposed to see this yet. So what Oracle does then, it stores the undo block address. So it has information, where is the undo stored? So I go to, or first I make a copy of the block, just straight copy. I go to the undo and regenerate the block. And see, now I've got a new system change number. This is how the block was when I was at 2965. And see, it was still changed then. So I have to make another, Oracle has to make another block. And go again to this new undo block. What was the block before this? Or how do I get to the block before this? Well, I read the undo, Oracle reads the undo, regenerates the block as it was before that change, or before that undo. And I see that my system change number is 2909. That is what I'm supposed to see. And I return the value. Have you ever gotten this? 1555 or a snapshot to all. Okay, let's see what that is. Well, when I try to apply this block, the data, the change was committed. Maybe, let's say it was committed. But even if it was committed, I'm not supposed to see it because my query started before that change actually happened. So I'm going to see the query as it was. But because it's committed, Oracle doesn't guarantee anymore. So if there were so many things going on in my database, it might need that information. If it wasn't committed, it would never allow it to overwrite the undo. But if it was committed, it might, if it needs space, overwrite it. And then you get 1555. It cannot recreate that block anymore. Typically, if you try to delete a lot of data, if you try to delete millions of rows, it starts going. Suddenly, it hits 1555 and it just rolls everything back. Then you have to start to do it in portions. Do a for all and update, commit, delete, commit. Or even smarter, if you gonna delete 90% of the data, do a CTAS, create table as. Make a copy of the table instead, move the data that you really want, drop the old one, and rename the new one. A lot faster, no redo. Okay, so what about the rollback? Rollback is basically exactly the same thing. I have some data, I have 2 blocks, I have Roy, I have Tina, I have Axel. I add a row, I add Mia. Oracle generates a change, that's a delete. So now I got Mia. In my transaction, I also do an update. I set the name to Ray instead of Roy. Oracle generates an undo record, and it's stored in my transaction table. That's my transaction ID of my session. So whenever I want to roll back, I go to my transaction, Oracle goes to my transaction table, roll back first, Ray to Roy, and deletes this, and I'm back. Okay. This is basically how Oracle works. This is the fundamentals of Oracle. And it's actually very important to know, because if you want to switch to another database, like Sybase, like SQL Server, this story could be completely different. So I'm fine if you want to go. I do that. If I don't need an Oracle database, I don't want to pay that money. I use my SQL or Hadoop or whatever. But be sure that you know what you're doing, because that database might behave completely different. It might be okay, it might not be. It might require a total rewrite of your application. And if your goal was to save money, that might not be what you do. So, a lot of this stuff is covered in one of the books of Jonathan Lewis, Oracle Core. It's very deep, but it's good. So, I hope you got some internals, at least got some interest for that. Those internals really matters. You need to know your database, or at least have somebody on the team that knows. And that might not be a DBA. Because Oracle DBAs, they know how to create tables. They know how to do table spaces, backup and stuff. So if you're in a project and somebody says, well, you have the DBA, ask him, do you really know what requires to be in a development project? Have you ever done that before? Because if the answer is no, he's probably not going to contribute in your project at all. And I've seen that happen so many times, that you have DBAs, look at it in projects, and they don't do squat. That's why you hate them, isn't it? That's why I'm here. I'm a consultant. Okay, any questions? No, if you have several restore points, you will have save points. And that will work exactly the same. Save point with a system change number will know exactly where to go. Yep. Anything else? You're just waiting for lunch, aren't you? Thank you. Have an excellent day.